The Agile Manifesto, written in 2001, lists 4 core values and 12 principles that guide how software, and increasingly any product, should be created. 1. Individuals and interactions over processes and tools. Think of a kitchen. A skilled chef and good teamwork produce a better meal than a fancy oven alone. In business, this means empowering people to collaborate rather than forcing them to follow rigid paperwork. 2. Working product over comprehensive documentation. A prototype car that runs is more useful than a 500-page design spec. Companies see faster market entry and earlier feedback, reducing the risk of building the wrong thing. 3. Customer collaboration over contract negotiation. Imagine a tailor who asks the customer to try on the garment while stitching instead of just reading a measurement sheet. This leads to higher customer satisfaction and less rework. 4. Responding to change over following a plan. A sailor adjusts sails to wind direction rather than sticking to a pre-drawn route. In business, this translates to the ability to pivot when market conditions shift, preserving revenue and relevance. Principles such as welcome changing requirements and deliver working software frequently encourage short-cycle sprints and continuous improvement. The business implications are quicker ROI, lower waste, higher employee morale, and a culture of learning. Companies that adopt these principles often see a 20 to 30% reduction in time to market and a measurable rise in Net Promoter Score because they can incorporate real-world feedback early and often. Scrum is a lightweight framework that turns the Agile values into a repeatable process. It has 3 roles, 3 artifacts, and 5 ceremonies. Roles. Product owner PO, the voice of the customer. The PO owns the product backlog, decides what brings the most value, and says yes or no to work. Analogy: a movie director decides which scenes make the final cut. Scrum Master SM, a servant leader who removes impediments and ensures the team follows Scrum rules. Think of a traffic cop who clears blocked intersections so cars, the team, can move smoothly. Development team, a cross-functional self-organizing group that turns backlog items into a potentially shippable increment each sprint. Like a pit crew that can change tires, refuel, and fix minor issues all within a few minutes. Artifacts. Product backlog, an ordered list of everything that could be done. It is a living document that the product owner continuously refines. Sprint backlog, the set of backlog items selected for the current sprint, plus a plan for delivering them. It is the team's to-do board for the next 2 to 4 weeks. Increment, the sum of all completed backlog items at sprint's end, meeting the definition of done. It is a usable product slice, like a new chapter added to a book. Ceremonies. Sprint planning, the team decides what can be done and how. It is the cook prep phase before a meal. Daily Scrum, stand up, a 15-minute sync where each member answers, "What did I do yesterday? What will I do today? What blocks me?" Comparable to a quick huddle before a basketball game. Sprint review, the team demonstrates the increment to stakeholders and gathers feedback. Like a runway fashion show where designers get real-time audience reaction. Sprint retrospective, the team reflects on the process and decides improvements. It is the post-mortem of a ship's voyage to make the next trip smoother. Backlog refinement, grooming, ongoing activity to break down, estimate, and reorder items. Similar to a chef tasting sauces and adjusting seasoning before the final dish. Velocity is a simple metric that tells how much work a team can finish in one sprint. It is expressed in story points or any unit of effort and is calculated as velocity I equals the sum from j equals 1 to n of story points, j, where I is the sprint number and n is the number of completed items in that sprint. Teams usually average the last 3 to 5 velocities to predict future capacity. V bar equals the sum from k equals 1 to m of velocity k divided by m. If a team completed 30, 28, and 32 points over 3 sprints, the average velocity is 30 plus 28 plus 32 divided by 3 equals 30 points per sprint. Sprint burned on chart visualizes remaining work each day. The y-axis shows total story points left. The x-axis shows days of the sprint. The ideal line is a straight diagonal from total points at day 0 to 0 at the last day. A real line that stays above the ideal indicates the team is ahead, finishing early. A line below shows they are lagging. To interpret. Flat segment meaning work blocked or no progress. Steep drop meaning a big item completed or a bug fix. End of sprint gap indicating risk of not delivering the committed increment. In practice, a product manager can use velocity to forecast release dates and use the burndown to spot risks early, much like a pilot watches the fuel gauge and altitude to adjust the flight plan. Prioritizing the product backlog ensures the team works on the most valuable items first. Two popular techniques are MOSCOW and weighted shortest job first, abbreviated WSJF. MOSCOW stands for must have, should have, could have, won't have this time. It is a simple 4-bucket classification. Must essential for the product's core purpose, for example login feature for a banking app. Should important but not critical, for example multi-language support. Could nice to have, low impact, for example theme customization. Won't deferred or rejected, for example integration with a legacy system that will be retired. This method helps stakeholders quickly see trade-offs and align expectations. WSJF is a more quantitative approach used in SAFe. It calculates a score for each backlog item. WSJF equals cost of delay divided by job size. Cost of delay combines business value, time criticality, and risk reduction or opportunity enablement. Job size is the effort estimate, often in story points. Items with the highest WSJF are placed first because they deliver the most economic value per unit of work. Example, feature A cost of delay equals $120,000, size equals 8 points, resulting WSJF equals 15. Feature B cost of delay equals $90,000, size equals 3 points, resulting WSJF equals 30. Although feature A has higher total value, feature B gives a better return on effort and would be prioritized first. This technique encourages data-driven decisions rather than gut feel. Estimating work is a core Scrum activity. 3 common methods are story points, planning poker, and velocity-based forecasting. Story points are an abstract unit that captures relative size, complexity, and risk. Teams often use the Fibonacci sequence, 1, 2, 3, 5, 8, 13, because the gaps emphasize uncertainty as items get larger. For example, a simple UI form might be 2 points, while a complex integration could be 13 points. Planning poker turns estimation into a collaborative game. Each participant holds a deck of cards with point values, reads a user story, discusses it, and then simultaneously reveals a card. If estimates diverge, the high and low scorers explain their reasoning, and the team re-votes until consensus is reached. This process surfaces hidden assumptions and builds shared understanding. Velocity-based forecasting uses the average velocity, see topic 3, to predict how many sprints are needed to complete a set of backlog items. Formula: sprints needed equals the sum of story points divided by average velocity. If the remaining backlog is 150 points and the average velocity is 30 points per sprint, the forecast is 150 divided by 30 equals 5 sprints, approximately 10 weeks for a 2-week sprint cadence. This helps product owners set realistic release dates and communicate them to stakeholders. Cost of delay, COD, quantifies the economic impact of postponing work. It answers the question, how much money do we lose for each unit of time we wait? The basic formula is, cost of delay equals user business value times time delay, where user business value can be expressed in dollars per month or per quarter. Example, a feature that could generate $50,000 of monthly recurring revenue, MRR, will lose $50,000 for each month it is delayed. Economic prioritization models build on cost of delay to rank work. The most common is WSJF, explained in topic 4, where WSJF equals cost of delay divided by job size. A higher WSJF means a larger economic loss per unit of effort, so the item should be done sooner. Another model is opportunity scoring, where each backlog item is scored against strategic goals, for example market share, compliance, and weighted by probability of success. By converting strategic intents into monetary terms, decision makers can justify why a low complexity, high cost of delay bug fix jumps ahead of a high complexity, low cost of delay new feature. This disciplined approach makes prioritization transparent to investors and senior management. When a single Scrum team cannot handle the size of a product, organizations adopt scaling Agile frameworks. Three popular options are Scrum of Scrums, SAFe, which stands for Scaled Agile Framework, and LSS, which stands for Large-Scale Scrum. Scrum of Scrums links multiple Scrum teams, typically 3 to 9, through a coordination meeting. Each team sends a delegate, often the Scrum Master, to discuss what was done, what will be done, and any cross-team impediments. The meeting is short, 15 to 30 minutes, and acts like a higher-level daily stand-up, ensuring alignment without recreating a massive backlog for the whole organization. SAFe provides a full-stack hierarchy. At the team level, Scrum teams use standard Scrum. At the program level, multiple teams, typically 5 to 12, form an Agile release train, abbreviated as ART, that delivers a program increment called PI, lasting 8 to 12 weeks. PI planning is a 2-day event where all teams plan together. At the large solution and portfolio levels, enterprises that need to manage multiple ARTs, strategic themes, and budgeting use additional structures. SAFe adds roles such as release train engineer and artifacts like lean portfolio canvas. LSS keeps things lightweight. It scales Scrum by applying the same rules, events, and artifacts to a single product backlog shared by all teams. LSS has 2 variants, LSS up to 8 teams and LSS Huge, more than 8 teams, which uses requirement areas to break the backlog into logical sections. The goal is to retain Scrum simplicity while adding a minimal coordination layer. Choosing a framework depends on organization size, regulatory needs, and existing culture. Small to medium enterprises often start with Scrum of Scrums. Large, regulated firms may favor SAFe for its explicit governance. Companies that value minimal overhead may adopt LSS. Definition of ready, do-are, and definition of done. Do-D are 2 checklists that bookend a Scrum item. Do-are states when a product backlog item is ready to be pulled into a sprint. Typical criteria include clear acceptance criteria, estimated in story points, no open dependencies, and UI mockups attached. Analogy: before a construction crew can start building a house, the blueprint, permits, and materials list must be complete. If do-are is not met, the team may waste time clarifying details mid-sprint. Do-D defines what complete means for an increment. It often includes code written, code reviewed, unit tests passed, integration tests executed, documentation updated, and the feature deployed to a staging environment. The do-D is a quality gate that ensures every increment is potentially shippable. Quality assurance metrics tied to do-D and do-are include: defect leakage ratio equals defects found after release divided by total defects found. A low ratio indicates that the do-D testing criteria are effective. Cycle time is the time from when an item meets do-are to when it meets do-D. Shorter cycle times reflect smoother flow. Rework percentage is the proportion of story points that had to be re-opened after a sprint. High rework signals that either do-are was weak, unclear requirements, or do-D was insufficient, inadequate testing. By tracking these metrics, teams can continuously tighten their do-are and do-D to improve product quality and predictability. Agile governance ties the iterative work back to strategic business outcomes, using key performance indicators, KPI, and return on investment, ROI calculations. Velocity forecast accuracy equals planned story points divided by completed story points times 100%. Helps assess planning reliability. Lead time, time from idea entry to production release. Shorter lead time means faster market response. Customer satisfaction CSAT, or Net Promoter Score NPS, captured after each release to gauge user value. Burn-up rate, cumulative work completed versus time, indicating progress toward a release goal. ROI evaluation in Agile uses incremental delivery. For each sprint, estimate the incremental value, for example, expected revenue or cost avoidance, and subtract the incremental cost, team effort times hourly rate. ROI sprint equals incremental value minus incremental cost, divided by incremental cost times 100%. By aggregating ROI across sprints, executives can see how early releases contribute to the overall business case, rather than waiting for a big bang launch. Governance boards often require a minimum viable product MVP ROI threshold, for example 25%, before green lighting further investment. Tracking these metrics provides transparency, justifies agile funding, and aligns team output with corporate strategy. Explain how the 4 Agile Manifesto values influence stakeholder communication. Individuals and interactions prioritize face-to-face dialogue, so stakeholders receive frequent informal updates, for example sprint demos, rather than static reports. Working product over documentation means stakeholders see a usable demo each sprint, fostering trust. Customer collaboration over contract negotiation ensures stakeholders are consulted during backlog refinement, allowing scope adjustments. Responding to changeover following a plan lets stakeholders modify priorities without renegotiating contracts, preserving agility. What are the 3 Scrum artifacts and how does each support transparency? Product backlog shows all known work and its order, so anyone can see what is planned. Sprint backlog displays the team's current commitment and task breakdown, making daily progress visible. Increment the potentially shippable product slice demonstrates the tangible outcome of a sprint, confirming that the definition of done has been met. A team's last 5 sprint velocities are 28, 32, 30, 27, and 33 story points. Calculate the average velocity and estimate how many sprints are needed to complete a remaining backlog of 150 points. Average velocity equals open parenthesis 28 plus 32 plus 30 plus 27 plus 33 close parenthesis, divided by 5 equals 30 story points per sprint. Required sprints equals 150 divided by 30 equals 5 sprints. Compare MoSCoW and WSJF prioritization. When would you choose one over the other? MoSCoW is a categorical qualitative method suitable for small teams or when business value is hard to quantify. WSJF is a quantitative model that incorporates cost of delay and size, ideal for large portfolios where economic trade-offs must be explicit. Choose MoSCoW for quick stakeholder-driven decisions. Choose WSJF when you need data-driven ranking and ROI justification. Define cost of delay and show how it is used in WSJF calculation. Cost of delay measures the monetary loss per time unit for postponing a feature. WSJF equals cost of delay divided by job size. By dividing the economic loss by effort required, WSJF ranks items by the